you. Haven't even started yet. Before I do start, I have to do a little bit of advertising because I was told to. I work for a company called Modano, and we're hiring, and we really want some really good data scientists. We're a data company, so we're bringing artificial intelligence into project management. So we have big ideas like bringing things like intelligent resource management into the future of project management. So say, can we predict when people are taking holidays, who's the best person to replace this person, and so on and so forth. We're only 2 years old. If you were to come to work for us, you would have you would initially start off on client side. So right now we're working for a major bank, basically building their data innovation lab and bringing that into, basically getting them ready for the open banking era. So I actually don't work for MuzMatch. The CEO of the company is a friend of mine. This is what I do in my free time because I don't have a life. So MuzMatch, basically, it's a mobile application, and it allows people to meet for the purpose of marriage. Now, it seems like a very big thing to say, like, for the purpose of marriage. It's like, you know, if you have commitment issues, this is going to cause problems. It works in a very similar way to Tinder, apparently. So what you get is, you would get like a screenshot of a person with their name, their location, a little bit about them, and on top there you'd have a status message. What you would do then is you would click, if you're interested, you could either just say, yes, I like them, or you could click on it and it will open up and it will tell you a little bit more about them. And they would sort of have what's called a long description, which is an explanation of how they've decided to describe themselves. Now, one of the options that you have on MuzMatch is to blur your photo. And apparently, I don't have this data, but apparently 90% of women blur their photos. So if you're a man on this app, you're actually deciding whether you like this lady or not based on the other information and not whether you think she's pretty or not, which is cool. So like I said, it has been described as Tinder for Muslims. They do have other little things in there which does make it separate to Tinder. So that you have the option of having a wali. So a wali would be somebody like monitors how you're talking to people. I don't know anybody that's used it. You do have other things like you would define your level of religiosity, what sect you belong to, and so on and so forth. You could view, like I said, you could view further details. You could then like the person or you could pass the person. And that information is actually stored. You do have filter settings as well. So you can filter on age, location, profession, age, location, ethnicity, marital status, as in like single, divorced, annulled, widowed, whatever. And you also have the option of blurring your photograph. And once you match with somebody, your photo is not automatically unblurred. It's only if you kind of like, oh, well, you know, I can't trust this person, I'll let them see what I look like. So the aim of this project was multifold, and it wasn't just because it was data and I wanted to play with it. We did want to sort of identify trends in users' interactions. So the CEO wanted to get an idea of how people were interacting with each other. We wanted to identify differences in behaviors between different age bands, genders, and ethnicities, and identify commonalities between successful profiles. And the reason for that is, well, could we then sort of make suggestions to people? Well, do you need to write a little bit more? You need to write a little bit more about your hobbies, what you're interested in. Unfortunately, I didn't have who blurred and who unblurred their photo, but I was thinking, well, suggesting that they unblur their photo might have been a good thing as well. There was other things as well, like, you know, when you sort of in this realm of matchmaking and love and whatever, people sort of come up with all these urban legends and myths and reasons why things aren't working. So people will say, oh, well, you know, men only want to talk to young women, and men will go, oh, women only want to talk to doctors. And within the Muslim community itself, they go, oh, well, you know, we're all Muslim, you know, we're all equal. But then they have these ideas of, well, when you get down to it, ethnicity comes into play. So I wanted to I wanted to see this. I wanted to see if it's actually true, if the data actually supports whether ethnicity is a big deal or not. Spoilers, I haven't been able to figure that one out yet. I just chucked everything into Mongo. It's an unstructured database. I have very little experience with databases, and so I can tell you this is actually quite easy. If you're used to dealing with JSON files, if you're used to dealing with dictionaries in Python, this is actually quite easy. Like even the command to sort of ingest a JSON file is straightforward. I was then able to open up Mongo and clear out all the users that were inactive. Right. So the fields we had things like GPS-derived country name, GPS-derived location name. The ones in bold are the ones I decided to use. I didn't want to use a GPS-derived country name or location name because people move around, people go on holiday, and I only had a snapshot of the database. So I didn't really know where they were in general. I kept age. Country name was just used as a filter because this is actually a global app. So I decided, basically for data management purposes, I just have this little laptop. I was only going to look at people in the UK. I looked at their ethnic origin, or how they identify their ethnic origin, their gender, the long description. I didn't look at matches because you can derive that anyway. Obviously, member ID, status message, who I liked, who I passed, and who I viewed. I removed the things that were related to religiosity because this was just the first pass at the data, and the sect I removed because 99% of people identified with a single sect, so it wasn't even something that was going to be discriminatory anyway. So the last two, people who didn't like anybody and people who only liked inactive users, made up about 2,000 people. So we're still dealing with quite a large data set. So when we did the first pass at the data, we found just basic things. So the ratio of men to women was about 2 to 1, so you have twice as many men as you have women. So again, this is in the UK, the ethnic, so you have over half of people identify as Pakistani, and then it goes Bangladeshi, other. Now other isn't mixed race, because mixed race is in there. You've got Indian, you've got Arab, and then I can tell you, like these ones here, one of them says Iraqi, so I'm not really sure why we have Arab and then Iraqi as separate ethnicities in there. Another interesting thing that, again, I wasn't able to answer in this one is that, well, the majority of Muslims in the UK, in the world, are Indian, so how come the majority of users are Pakistani? I don't know. And then when you look at the distribution of ages, I've been, not very politically correct. Red and pink would refer to women, and blue will refer to men in this talk. So this is the age distribution. You'll see initially the majority, so a lot of men so in the very young age group, so this is between 18 and 20, the youngest is 18, I think that's youngest is 18, so this is between the ages of 20 and 25. You do have more men than women in that group. They kind of even out, so the majority of users are in the late 20s, and then as you get a bit older, the ratio of women to men actually increases. I then had a look at how many people liked. So we found that men, so this is a logarithm, so this basically means this is kind of a frequency count of the number of people who liked 100 people. So you'll find that the maximum number of women that men liked was about 13,000. So there's a guy on there that has liked about 14,000 women. The app is only 2 years old. I don't know how. Honestly, I mean, just physically, how do you do that? Unless there's a bot that you can write that can go in and do that. I don't know, I don't have that capability. There is a woman or a couple of women in there who have liked about 7,000 men. And at minimum, they like about 1. The average number of women that men like is about 1,000. And the average number of men women like is about 194. So if you look at the median and you just look at the standard deviation, you find that men, on average, like between 39 and 251 women. And then women like between 6 and 39 men. So it's quite a difference. So if you're familiar with OKCupid, the guy that works there, the data scientist, wrote a book, I think, called Cataclysm, and like a bunch of blog posts on this. And one thing he looked at was, well, what is the correlation of ages between sort of what ages are women interested in and what ages are men interested in? And does that actually change over time, so as they get older? What you see here, so if you take 30, you'll see that this is the female age. So women in their 30s have liked men between the ages of 20 and, say, 42. The size of the blobs shows the frequency. So even though she might have liked somebody in there's some women who have liked men in their 40s, the majority of them seem to have liked men in this case. And then I did a very simple linear regression, like linear fit. And I found that on average, so the slope here is about 0.5. The older women get, the older the men they like get. This is the plot for the men. Obviously, the balls are bigger because there's more men on there and they're actually more active. And you'll notice that even though, like, as the woman gets older, these dots sort of in the young age group kind of get smaller and smaller or sparser. This isn't the case in the terms of men. So if you get men in their 40s who are still quite actively liking women in their very early 20s. This is not 1 or 2 dots. This is like a large number of men in these age groups are sort of liking that. And the slope here is about 0.02. So there isn't much increase in the female age as the men get older. Unfortunately, I didn't have the profession details, so I couldn't actually challenge the other things that sort of the other urban legend or myth. I then looked at the number of days people were active. So you find that the majority of people who have only been active for about 100 days. You do have people who have been on there from the very beginning that the app has started. And this shows you, this is in general, like, and then I looked at the number of people that people liked, again, in general, over the course of time. And you'll find that, yeah, the majority of people liked less than 200 people. I was trying to find a correlation between how long people were on there and how active they were on the app. Now, I then looked at impression, which is how many people saw your profile. Now, remember, there are filter settings on here. So just because you're on the app doesn't mean that somebody's actually going to see you, because you might not match their filter settings. So what you do, I don't actually have that data directly there. So what I did instead was I looked at the number of likes a person got, and it added to the number of passes they got. So that shows you how many people saw you, or gives you a rough idea of how many people saw you. And so we'd have a look. You see that in the case of women, the majority of them have a kind of high impression under the age of 30. And for the men, they kind of have a high impression between the ages of 30 and 40. That kind of shows people's preferences, even though I didn't have that data directly. And this is something that I will then use to identify something called popularity. Now, as I mentioned in the beginning of the talk, you can either like somebody directly, or you can have a look at their profile first and have a think about whether you really like them or not. So I decided that really liking somebody meant you actually made the effort of reading their profile as well. So I defined the real likes as the intersection of user IDs of people that had been liked and people you liked and people who you had viewed. And then defined the popularity as the number of real likes you got divided by the impression that you make. So if somebody saw your profile, how likely are they to like you? And I found that, so basically a popularity of 85 in this case would mean that 85% of people who viewed your profile would have liked you. Before I show you sort of the popularity stats, this is what it looks like when we plot the likes and the real likes. So the blue dots, the crosses show you the real likes. So this is the intersection of the number of times you viewed a profile and the number of times you've liked somebody. And the blobs are the number of times you've actually liked a person. So as you can see, if you have for less than 2,000 likes, the number of times you like somebody and the number of times you actually make the effort of looking at their profile are pretty similar. Obviously, when you get to silly numbers of huge numbers of likes, you will find that obviously people don't actually make the effort of looking at about 2,000 profiles. So I think, most people are just going yes, 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 yes. Maybe because they're right-handed, I don't know, and the tick is on the right hand of the screen. So then we look at the redefined popularity. So this is the popularity, which is the number of real likes divided by the number of times somebody has seen you. And then I just took a little histogram of that. So again, the red is the women and the blue is the men. So remember, if you have a score of 85, 85% of people that saw your profile liked you. And you can see a massive difference between the behavior of men and women here. So you find that the vast majority of women, if their profile gets seen, 87% of the time it'll get liked. If you're a man, that's 10%. What are the urban legends sort of when you do these, when you sort of, going to singles events and stuff, is that they say that men are very picky. They're not. It's women who are. So then obviously the question, well, what makes a person popular? What separates the people that are getting over 90% of likes from those who are getting in the lower band? Now, for women, you just have to have a profile. And I mean, at least you will get 60%. So 60% of people who are going to view your profile are going to like you. So I defined an unpopular profile for women as having a popularity score of less than 60, whereas for men I defined it as being less than 20. And in both cases, you would be super popular if you got a score of more than 90. So I thought, well, maybe they're grouping into ages. Maybe you're popular if you're young. No. So you find that the average age for women is in their late 20s. So it's not 23 like OKCupid found. And then I looked at the number of words they use to describe themselves. And you find that in the long description, again, there's very little difference. You find that the popular women in the women who are scoring greater than 90 and those scoring less than 60 are using practically the same number of words in describing themselves in both their long description and their status message. For the men, I would say there is a clear difference. If you are getting more than 90 likes, or if your popularity is greater than 90, you're actually using significantly fewer words. Again, this is counterintuitive, but and then the status messages, they're all pretty much the same. The other interesting thing is that women who are scoring, the popular people with scores higher than 90 tend to like fewer people than people who are scoring in the lower cases. So women who like less than 60 people have actually liked about 300 men, whereas men who are scoring less than 20 have liked about 2,000 women. It's the only difference that I can find. But there's nothing else sort of in the description of the person themselves. So I decided to do a random forest. Because I can't be bothered to go through all the different features and sort of see, well, does this make them more likely to be popular or not? So I binned the ages, I binned the number of people that they liked, I took the lengths of the long description and I binned that, I took the status message length and I binned that. I did a bit of TF-IDF and a bit of NLP. Now in this case, I basically, I grounded the words, so I created a little function. By the way, there's a Python notebook that you can have a look at if you ever want to. So what you do here is you split the words, and then you then find how many words, you then try to find the synonym of each word. So I was interested in content, not necessarily the exact words that they were using. So if they were using words like hello and hi and hiya, I wanted to sort of ground them all to the word hello. I then ran it through TF-IDF vectorizer, which is the standard Python thing, but I chose number of features. So for the status message, I took the top 50 features, so the top 50, the words with the highest TF-IDF score, and then I took the top 100 features. Do I need to explain TF-IDF to this? I don't think I do, right? Yeah, you've heard a lot about it. This is why I'm not going into my Python notebook, because I think you've had a lot of that. And you're at this talk because you want a bit of intellectual break. I then took the 100 features in the long description as well. And I basically did a bit of a one-hot encoding, and that's how you got those features in there. I then looked at the ethnicity and the number of days that they were active on the app. I shoved this through a random forest, did a bit of cross-validation, and I found that the likelihood of you having a popular profile, or me being able to identify whether you have a popular profile or not, is 50%. So it's like as good as guessing. So basically, using this method, I wasn't able to find anything different between the profiles. So why are some people having high scores and other people having low scores? So I turned to graph theory. And so the question is, at least can I answer the question, do birds of a feather flock together and ignore the other little birds? So initially I tried to use Neo4j. PyTineo is a really nice little library for Python. I crashed my laptop several times. I then got an account with DigitalOcean and tried to get Neo4j working on there, and it refused. It crashed that as well. So I just went to NetworkX. In actual fact, NetworkX is really easy to use. I was surprised. I created an undirected graph in the network. And the reason you have to do an undirected graph in the network is so you can use their Python, their community detection algorithms. And I filtered out people who had liked over 300 people. This is not actually a very intelligent way of doing it. I actually wanted to keep everybody in there. But even there, and I got like 7 million connections or edges in the graph when I did this. And there are people in there that like over 10,000 people. So that would have actually created a massive graph that the laptop couldn't handle. And I found that 300 was enough. That was basically the number of people, the number of nodes, or the number of edges per person that it could handle. I then used something called Louvain modularity to find the communities. Now, when you think of communities within a graph, you think of this graph that's all well connected. And you find like you can actually then identify subgraphs by randomly removing nodes. And once, if you remove a node and a graph sort of becomes disconnected, you can actually identify that as a graph, as a community, which actually works well for sparse graphs. But this is actually it's a very dense graph, and that would have taken forever. And I think in the end, you would have just found a community is just like one node or two nodes. So Louvain modularity does something a bit, I won't explain it because I haven't actually done the maths. I just understand it as kind of like a density thing. So it calculates the density of nodes, and it finds the smallest community which has a high density with respect to with respect to the density of the graph itself. And then it identifies communities that way. And it's basically marketed as a way of actually finding communities within a very dense graph. So I did that. It's actually quite a neat way of doing it. I'm actually quite proud of this bit. If I just noticed I had some time, so I'll show you that I've actually done stuff and not just made these numbers up. See, I have a Python notebook. It's a very messy Python notebook. I do have it on GitHub, and if you're lucky, I might tidy it up before you guys have to look at it, but I doubt it. So you can just go through it. So where's the graph stuff? So here's the graph stuff. It's really easy. So this is where I did the directed graph, and that's because I wanted to identify who passed me. If you remember, that wasn't actually in the initial JSON dump. So what you do is you just initiate a graph. In this case, it's a digraph, directed graph. You read in the CSV file. So I just basically created a CSV file of every 2 nodes that were connected. And I don't know why I'm reading the doc twice, but and then you literally just add them. And it's actually very, very fast. Why was I showing you this? Because I wanted to show you the Python. Yeah, so it is really, really easy to add that in and to create a little network graph. And this is literally all you have to do to identify the communities. You just use the community library, which comes with the NetworkX package. You might have to install it separately, I can't remember, but I think it might be come as standard now. And you use something called best partition, and that actually identifies the optimum number of subgraphs within the graph itself. You can actually identify the number of subgraphs that you want to look at, and it will identify which nodes are part of that. And then all you do is once you have the communities, you can actually find how many, you can then find who is in which community, and then you can do some little analysis on that. Sorry. My mouse is a bit annoying. So I identified 7 communities. We wanted to look at, so each community had between 1,000 and 4,000 members each. Then you had a look at what each community looked like. Again, pink is for women, blue is for men. I lack imagination. You find that again, so to be considered popular, so your popularity is high if you have more than 80, if your score is about 85, if you're a woman, and it's about 14 if you're a man. You'll find that is pretty much standard across all the communities. The ages, again, they're standard. Community 4 seems to be the older community, so the average age for men is about 41, the same for women. And then you have community 6, which is kind of the younger age group. So women are about 23, men are about 24, but the others are all pretty much standard. The length of the status message is pretty much the same across all the communities, as is the length of the long description across communities. I mean, you find that the top 2 communities, the men are using more words than average than the other 4, but again, it's not significant. Well, it's not a massive difference. What I did, so we had actually already filtered the status messages, and we'd filtered the long description based on our TF-IDF vectorizer, and then I did a bit of a count vectorizer on that as well. I wanted to see if some communities were using different words to other communities. So 6F means that community 6, the women in community 6. And then if you look at the men in community 6, they're kind of using similar words, so looking and love are pretty important. But then that's pretty much the same for community 3. The only difference is that community 3, the men might be, it's the same words again. So, I mean, as in having a high frequency. So, I didn't find any difference in the communities in that case. So I don't think I can let this go. I think I'm going to keep going at it until I go crazy. So again, my NLP was quite basic. I was only looking at phrases. I might want to take this a bit further and start to look at, bigrams, trigrams, whatever. Maybe, I don't know if I will do that. I also want to look at the quality of the language. So right now I'm not actually, even though I'm using a dictionary to find the synonyms, I'm not actually capturing how much of the words that they're using is actually well spelled or real words or whatever. So I might want to capture that as well for the next one to see that might be something that's might be different. I also want to look at the dates that they're active. So sometimes simply being active at a certain time in the year would mean that your people are more likely to view your profile and therefore more likely to like you. Looking at things like GPS location, but I would need like several snapshots to identify where the person usually is, and also get data on profession and educational level. I think that's it. The notebook and the various different Python modules are up on the on my GitHub repository. The Python notebook is still a bit of a mess, but if you want to sort of have a look at how I did the network X graph and do the community detection and how I did the machine learning random forest stuff, you might want to have a look at that. And I will probably be adding a README file in the future. So thank you for your time. And if you have any questions or feedback, that would be really awesome. Like if you have any insight on what else I could do, what I'm doing wrong, that would be awesome. Thank you.
Any questions?
Yep, oh dear.
Yeah, I was wondering with the network stuff. So you use nodes, not edges, for the communities. Is that correct?
So you use both. So you actually have to look at how they're connected. So basically, what you're doing is, it's easy for me to imagine using the betweener centrality to define communities. So what you do is you cut off edges until finally you have a standalone subgraph, and then that would tell you that's a community. And
how big was your network and the performance? Because I've tried that like recently, and I found that like once you get to like 500 nodes, which are quite dense.
So no, this is the number of nodes. So in total, the number of people I had in the UK was about 20,000. Once I cut off the number of likes at about 300, that went down to about 10,000. So I had 10,000 nodes, and some of them have about 300 nodes coming out of them. So you're looking at about a few million edges in there.
And then that went very quickly.
It was quite reasonable, yes, in this case. Building the directed graph is slower. Building the undirected graph is quite fast, and yeah, as long as you're not running anything else, the partition community detector seems to be within minutes, so it will run with quite a large graph. So yeah, welcome.
I was just wondering, how do you know that by discarding inactive people who'd only ever previously liked inactive people, you're not actually removing the most successful people who joined up early, found the love of their life, and stopped using their profile?
That's a brilliant question. I didn't think of it. One of the issues I have with the officially inactive profiles are I don't have any data on them. I just literally have their member ID and the fact that they're inactive. But definitely I will be using that if I do continue with this. So this is my hobby. I'm not sure. I don't get paid for this. But no, I like that. Thanks.
In terms of the actual data analysis, are there really any differences between this being a sort of Muslim marriage app rather than a standard sort of like, I don't know, more an app with a wider audience? And therefore, can you not just steal a load of other people's methods?
I did actually. So the only thing that I've done here that I've not read about, well, I've done the machine learning stuff and the network analysis, which I haven't seen before. But the things I'm sort of looking at the correlation of ages and stuff, I actually got from the Cataclysm book, and I got some of the inspiration from there as well. The thing that sort of would separate this from like a majority, an app that the majority would use, is things like prayer level, level of practicing and things like that, which I actually didn't include in the end. That might be something I want to look at in the future. And also, if I was then to look at the dates that they were active and sort of to find correlations with public holidays or major events, I would not be looking at things like Christmas and Valentine's. I would be looking more like the religious holidays within Islam as well. So yeah, but good question. Thanks.
Was there a good reason for not including the religiosity and ethnicity and kind of differentiating the communities in the network graph? Because I would have thought that might be.
I did put in the ethnicities when I was looking at the communities. The reason I didn't put it up there was because they were all the same. So you had the same spread of ethnicities across. There was one thing that I did find. So when it came to looking at the number of ethnicities in the popular and unpopular sets of men, they were liking, there was no difference. Whereas with the women, they were kind of, there was a difference, as in unpopular men, there were certain ethnicities in there that were not present in the popular women. But I didn't take that very serious. I mean, I wasn't sure whether to read into that or not, because we do have a very big bias towards a particular ethnicity as in the data itself. So I hadn't actually figured out how to deal with that yet. Yeah.
So I guess two parts. The first thing is any research on the making your picture fuzzy, because that seems to be very efficient in like keeping pervs at distance.
It's plot XKCD.
Oh no, but I mean like the
Oh, sorry.
the blurring of this. One of the key features of this app seems that you can actually blur your photo.
Oh, right, yes, I thought you meant
So
mine,
for
okay.
a life partner, it seems kind of nice that you spend time figuring out what the person's like instead of just what it
Yeah.
looks like. So that, and like, is there any effect of that you were able to see?
Again, that's the thing. In this particular data set, I didn't actually know who had their photos blurred and who didn't, which is unfortunate because I think that would have been quite important. And also, you would also, in the full database, you would also actually capture when they decided to make that picture visible or not, which unfortunately, again, I didn't have that data.
Then the second question, I guess, is so typically, this is more kind of like hindsight bookkeeping and sort of dashboards and stuff we have learned by just looking at the data. But typically, you would analyze data such that you can make a decision, and like with your app. So for example,
Yes.
hey, we're going to make the app better now because we just learned this one fact.
Exactly.
But that's also kind of tricky because you're actually sort of, this is a very personal data set.
Exactly, yeah.
So how is that relationship being dealt with?
So one of the things that we want to sort of make a recommendation on and how to improve it. Again, that's why I was so focused on sort of doing the text analysis, because you can't do anything about your ethnicity, your age, what you do, whatever. Who cares? But you can make an effort with sort of what you write. So if you make an essay, I was hoping that I was going to say, well, look, if you make an effort and actually write a proper description, you are going to have more meaningful conversations with people. You are more likely to meet people. Unfortunately, I found that actually a lot of people were being quite verbose in their long description in their status messages. So I wasn't able to find that. That was kind of where I was going with that. In terms of actually, you just made me think of something. The fact that most of the women have their pictures blurred might explain why men are so prolific in liking people. Because if you make a match, it is likely that then that photo would then be revealed, and then you could make a decision. So actually, viewing the yeah. So it's not. it could be that it's not a genuine like. It is like, well, I still want to make that decision. So yeah. Yeah.
So once people match, I guess they can chat with each other?
Yes, there's a chat service as well.
You didn't have any data on
No,
that?
that's
that
too.
would be quite interesting, even like how many messages they exchange,
Yes.
the length, the words they use.
That's something I wanted to do. I didn't want access to the actual what they were saying, but if it could be run remotely and sort of tell me, well, how many messages are being exchanged, how long before they exchange numbers. It's very easy to detect whether a phone number has been exchanged or a Skype handle has been exchanged. But then again, that would be an next iteration. But
you even work out like how frequently people date, because it would start like exchanging messages and then maybe for a few weeks and then it drops.
Yeah,
and
and
moves on someone else. That person.
yeah.
Be one way to weed out pervs as well.
Yeah, exactly.
So actually, they do have a way of doing that. So if somebody's sort of being inappropriate, you can actually you would report them.
I mean, like inappropriate, but like guys who just liking people just so they can see their pictures, because then you would never have a conversation. Right?
Yeah, that's true.
You know.
Oh, so it's not. So you actually still have. So the person still has to reveal their photograph actively. It's not like, oh, if you match with somebody, you have a picture. Yeah. So the people still have a lot of control over their image, I guess. So yeah, but that kind of data is really, really personal. I'm not even sure that I would be comfortable having it.
Yeah, we could just metadata.
Yeah, that'll be okay.
So you mentioned this book about OKCupid.
Mhm.
What was the insights in that? I mean, what was the
So the thing is with OKCupid, the guy that actually wrote it was the data scientist there, and they actually ran experiments on their users, which was, so they did things like for a day they would remove all photographs and see how people interacted, and then another day they would remove all text and see how people interacted, and they also had access to all the they had access to the conversations and stuff like that. Those conclusions were quite useless, I would say, because they say, okay, women like doctors, men like 23-year-olds. Okay, that's it. The insight wasn't as useful. There was another one that was done by another dating app, and that's when they actually looked into the conversations that people were having, and they found that the people that were having the long conversations were the ones that were genuinely successful, if you define success in this case as actually finding your life partner. So, which was actually, because again, they found the same thing. There was no difference in ages, in a level of attractiveness, in anything. The only difference between people who were genuinely successful and those who were not was that they spent more time talking. So, which was actually quite nice to know.
One more question.
Oh, sorry.
Can you show again the double plot with the for men and
The depressing plot, huh?
Is there like a Bumble there for both genders at 100%?
Yes. So this is not. This is kind of. This is binned. So this is between 95 and 100. So you do have people there who do have a score of 100. So everybody that saw their profile liked them.
Even for women like men?
Yes.
Do you think it's probable that they are some kind of bots or?
This is what I don't know. This would be interesting. I don't know how you would do it. I mean, I'm not a developer or a programmer or a hacker. So if it's possible, I guess yes.
I think it's probably possible that the thing is many times you can identify these kind of agents because their behavior is inconsistent with the.
Yep.
So through data analysis you can try to find those.
But I mean, like I know I said somebody like 13,000. It wasn't a single person. There were a few people that were sort of at that tail end.
Multiple bots.
Oh, multiple. Okay. Yeah. They did get filtered out when I did the machine learning and the community detection. So.
They're not user accounts created by the app development team themselves to test things, and actually it's just because they viewed 13,000 profiles and they've swiped that many times. Like their own
It's a
internal
reasonable-
account.
Yeah, it is.
Reasonable hypothesis.
But in that case, why would the men? Why, if that was created by the company, you would find that the number of outliers for men and women were the same, whereas there's significantly different. So you got 14,000 likes for the men, 7,000 for the women and the outliers. So. No. Possibly. Thank you.